Welcome to this model of the World Climate School course on climate change. The title today is Roadmap for an Ecological Civilization, Drawdown and the Economic Transition. Drawdown refers to the point in the future where for the first time the amount of greenhouse gases in the atmosphere starts to drop. As you know, greenhouse gases are increasing fast in our atmosphere, warming the planet, disrupting the climate, and threatening our livelihoods and even our lives. To avoid a climate catastrophe, we not only need to stop greenhouse gases emissions as soon as possible, we even need to sequester already emitted CO2 from the atmosphere. Currently, we are at about 415 parts per million, and only if we go back to around 350 parts per million, we will come back to a climate that is stable enough for our societies to live and thrive. We have this decade to turn things around and be on our way to create an ecologically and socially sustainable society and economy to avoid a catastrophe. My name is Rob de Laat. I live in Brazil, where I work on forest protection, reforestation and rewilding. Today's module is about this Drawdown project, which is developed by Paul Hawken and his team. Drawdown is a solution database for the large areas of the economy that we will need to transform in the years to come, to change the direction from climate catastrophe to the direction of a sustainable and just future for all humans. Drawdown shows the amazing amount of solutions we already have to reduce our footprint from energy, mobility, industry, food production, and land use, and the way we build and live. Today's lecture is a 1-hour introduction into the Drawdown project. The third pillar we show in this course to have a tool set to understand how we can transit the global economy and prepare for each person's role in this huge transition. Because the situation is dire, and only with a mass mobilization and transformation of our societies around the world will we be able to avoid the collapse of modern complex societies, which now are threatened by climate change and other interrelated crises. On this slide you see a short reminder of the 3 pillars of economic change we need to apply to make a transition to a sustainable and just economy, which we may describe better as an ecological civilization. In the last 2 sessions, we presented the circular economy and donut economics, which is a system theory of economy to replace the ideology of GDP, which works with endless growth on a finite planet which is currently destroying life support systems on our planet. Today we present Drawdown, the most comprehensive plan ever proposed to reverse global warming. Taken together, these 3 tools, circular economy, donut economics and Drawdown, will give us enough tools in our hands to help design a sustainable future. By 2030, the transformation of the global economy will be the largest economic activity in the world. At least if we humans finally take the challenge of climate change seriously. In this schedule, the most important areas are described. Transformation focuses on decarbonizing electricity and enhancing efficiency, reforming food production and land use, making industrial production more and more circular, electrify and smarten up transport, retrofit and create low energy use buildings, protect and regenerate degraded land and restore ecosystems, and improve basic access needs to all human beings, including food, housing, healthcare, and education. After this overview comes a much more detailed introduction into Drawdown, and enjoy the video which will give you a journey through all the solutions that are available. Thank you.
So today we're going to talk about climate solutions and a little bit about the science we need to understand to be good at solving climate change and what do we do moving forward. But before we talk about moving forward, sometimes it's useful to look back and figure out how did we get here in the first place? Because human beings have been on this planet an awfully long time. Our ancient ancestors, kind of the things that eventually would evolve into Homo sapiens, something like us has been on this planet for like, I don't know, 6 million years roughly. And during almost all that time, we've had some impact on our surrounding environment around us, nearby in the local area. But only recently did we have a tremendous global impact on entire planetary systems, just an extraordinary explosion of our footprint on the environment. And most of that happened in the last 50 years or so. And most of this happened basically because of a few basic things. One is there's just a lot more of us in the world today. In the last 50 years, our population has grown enormously. We've also become more urban and more concentrated as a species. For the first time in history, humans, more than half of us, live in a city. And that wasn't true for the previous 6 million years. And also our economic activity and use of technology and resources has also grown hugely in the last 5 decades. And just to put this in perspective, in the last 50 years, our population more than doubled. The economy grew between 5 and 6-fold. Our use of food tripled during that time. Our use of water roughly doubled. And our consumption of fossil fuels almost tripled in just 50 years. Think about that for a second. In the last 50 years, we've changed more than all previous human evolution and human history combined. The last 50 years changed more than the last 6 million years of human existence. And that last 50 years has caused us to disrupt entire planetary systems, not just a local environmental change, but now global systemic changes everywhere. Some of those changes are really obvious to us. We can see them, we can go out and walk around in them, we don't have to argue about them, we know they're happening. For example, we've been clearing forest, mainly for new agricultural land. This is a picture of part of the Amazon rainforest in the 1970s. And we went back and took the same picture again with a different satellite around 2003, seeing huge amounts of clearing, even in the most remote forest on Earth, primarily to grow more animal feed. This is soybean fields here. And that soybean product is being shipped mainly to China as feed for pigs. As China becomes wealthier, they're also consuming more meat, and those animals have to eat something. So soybean production in the Amazon, feeding pigs in China, is kind of a feature of our new globalized world. And because of all the pressures on rainforest over the last few decades and centuries, we've already lost almost 1/3 of the world's tropical forest cover, and we're losing a lot more every day. We've also changed the nature of water on Earth. There's still the same amount of water on Earth there was for the last few billion years. The same number of water molecules are somewhere, either in the ocean, the atmosphere, or in a lake or a stream or whatever. But we humans have used fresh water, which is very rare, in the places we need it at most. And we've had big consequences on the water cycle as a result. For example, this is a picture of the Aral Sea, one of the world's largest inland seas, at least it used to be, in the former Soviet Union in Central Asia. But the Soviet Union actually diverted the 2 rivers that fed the Aral Sea and filled it with water every year. They diverted those 2 rivers and used it to irrigate the deserts of Kazakhstan to grow cotton. And this is what it looks like today. We've literally erased one of the largest geographic features of Central Asia. And this kind of phenomena of collapsing water resources is not unique to Central Asia. It's happening in California, the Colorado River, the Agawa Aquifer, all just in the United States. It's happening in Iran, it's happening in North Africa, it's happening in Europe, it's happening everywhere. And so water resources are collapsing around the world too, another very visible sign of our kind of global environmental impact. So we've seen changes in land, we've changes in water and so on, but the one that's we're going to be focusing on now is changes to the sky, changes to the atmosphere itself and its climate. Now, we've known about this for a very long time, it turns out. that when we change the composition of our atmosphere, introducing more of these so-called greenhouse gases, which we've been doing for a while now, this will warm the planet. This is not up for any scientific debate at all. We've known this for a very long time. Starting in the 1850s or so, we began to increase the levels of greenhouse gases, one of which is carbon dioxide, or CO2. And since that time, CO2 levels have risen about 50% above what had been seen in the mid-19th century. In fact, it's higher now than it's been in the last 3 to 5 million years. What we're seeing now hasn't happened for a long geologic time. As a consequence of building up more of these greenhouse gases, the planet is warmed, roughly about 1 degree Celsius. And we can see if we overlay the temperature change with the CO2 changes, they line up pretty remarkably. It's funny, though, that we start this graph back in the 1850s because that's when science first realized that increasing the levels of CO2 could warm the planet. When I was in graduate school, I always learned that it was discovered around the 1860s by a guy named Tyndall from the United Kingdom. But it turns out, and the history books had not included this for far too long, it was actually an American woman named Eunice Foote, F-O-O-T-E, who actually first published a paper showing that increasing CO2 could warm the planet back in the mid-1850s, before anyone else. But as a woman scientist, her work was largely kind of set aside and ignored for far too long. Credit was given to other people in the meantime, and we've forgotten all about her. There's still not even a surviving photograph or painting of her today. We don't even know what she looked like. But I want to make sure we stop today and remember her contributions, not only to science, but she was also an early leader in the American suffrage movement to help give women the vote in the United States. So remember Eunice Foote. She's been ignored for far too long and deserves the credit, all the credit we can give her today. But here we have climate change. We know it's real. There's no debate about the basic science. The question now is, what do we do about it? This is an incredible challenge, to be sure, because as our climate changes, so do many other things, like our water, our ability to grow food, how sea levels will rise and maybe inundate our cities and coastlines, how ecosystems work, how all wildlife on this planet works. Our health, our economy, our security are intricately connected to climate. And if that changes, then so will everything we depend on. So that's an incredible challenge. But let me stop you right here and tell you, just cutting to the chase, it is not hopeless. If people tell you now it's too late to tackle climate change, or we might as well give up now, they're wrong. They're just as wrong as the people who denied that climate change existed. Between denying climate change and being a doomist about climate change and just giving up hope, both of those things are completely wrong. We have to find a middle ground where we roll up our sleeves and get to work and address a problem because we can. We can still build the future we want. The future isn't written yet. We get to decide what it is, and we can make it a good one. And addressing climate change will be essential for us to have a good future. Like I said, all these things we depend on, our water, our ecosystems, our food, our security, our health, our economy, depend on a stable climate that we've had for thousands of years. So if we want a better future, we have to address climate change, because if we don't, a climate change running out of control could disrupt everything we care about. Equity, justice, prosperity, resilience, culture, all of these things we care about could be made worse if we don't address climate change. So climate change is essential to a good future, and the good news is we can still address it. That's what we do at Project Drawdown. We're a scientific organization that studies climate solutions, but instead of just writing reports for other scientists, we share them with you and everybody around the world as a public resource to the planet around climate solutions. But why do we use this word drawdown? Why do we even refer to that? Well, drawdown refers to a moment in time that we are striving for. Let me wind back the tape a little bit. Here's a chart showing the levels of all greenhouse gases, CO2, methane, and a bunch of others we'll talk about later, starting in the mid-18th century and going forward to today. They've been rising dramatically since then. So here we are at the end of that curve. What's next? Well, we could continue to elevate those levels of CO2 and other greenhouse gases. And if we do, if that just keeps rising, so will the temperatures. As that curve goes up, so do the temperatures of our planet and disruptions to our weather systems and our whole ecosystem. But we don't have to do that. We don't have to have a bad thing get worse and get out of control. Instead, we can go and bend the curve. We've been hearing that phrase a lot lately, referring to a pandemic, but it's the same kind of idea with climate change. We have one track, which is a lot more diseases, or we could do smart things like wear masks and social distance and be careful and bend the curve on a pandemic. Same thing with climate change. We have one choice is disaster, or the other choice is we get smart and we bend the curve and we make it better. So when we bend the curve, we eventually will hit this point, that little blue dot. That is the moment of drawdown. It's the moment when greenhouse gases stop climbing, they stabilize, and then we begin to draw them back down again. So drawdown is a moment in time in the future when greenhouse gases stop climbing and they start to steadily decline. And that's the minute we stop climate change from getting worse. At Project Drawdown, that's what we're all about. Our mission is to help the world achieve drawdown, to get there as quickly, safely, and equitably as possible. But to do that, we first have to understand what we're doing and what the problem is and what the science tells us about what we need to do next. So here's the basic problem. There are a variety of so-called greenhouse gases that let solar radiation, the sun's heat, go right through the atmosphere and warm the Earth's surface. You know about that. The Earth then radiates back to the universe in the infrared wavelengths, and some gases absorb infrared radiation and re-radiate it back to the Earth's surface, warming the surface of the planet. That's the so-called greenhouse effect. But if we increase the level of key greenhouse gases, including carbon dioxide, methane, nitrous oxide, and a few others, we'll make the planet warmer. There's just no way around it. Well, that's exactly what we've been doing. We've been elevating the levels of three crucial greenhouse gases over the last 250 years, and especially in the last 50. There's another category of greenhouse gases I'll mention later called fluorinated gases that are also increasing. We just don't have as long a historical record of those. Now, where do they come from? Now, usually you're told that greenhouse gases all come from fossil fuels. It's burning coal and oil and gas. And if we just got rid of fossil fuels, we solve climate change. Well, if you say that, you're about 62% correct. That about 62% of the warming being caused by human activity today and greenhouse gas increases, when we level this all out on an equal playing field, about 62% of the warming we see now is being caused by the combustion of fossil fuels. So getting rid of fossil fuels will take out that part of the wedge. But there are other things that add to climate change as well, and we have to address these too. For example, CO2 is also released by other human activities besides burning coal and oil and gas. For example, making cement and some industrial processes chemically releases CO2 out of the air, into the air, I should say. Rather than burning something, it's just simple chemistry. When concrete is curing, it releases CO2 to the atmosphere. Another thing that releases CO2 into the atmosphere is deforestation. When we cut down and burn, especially rainforests, for example, we are burning carbon that's alive in trees. And it's very similar to burning carbon that's dead in coal. The atmosphere doesn't care. You're burning carbon either way. Both produce carbon dioxide. So that green wedge is CO2 contributed from deforestation and other kinds of land use. So that's important. Then we get into other gases like methane, or CH4. Methane is also known as natural gas. Some of the methane we're adding to the atmosphere, about a third of that wedge, comes from fracking, comes from coal mines and natural gas pipelines that are leaking. So that's kind of industrial activities, usually tied to our production of energy. The other 2/3 of the methane, though, we get in the atmosphere is caused by agriculture, primarily from cattle and a little bit from rice fields. My dog is causing us bit. Will you stop it? Sorry. That's my buddy Penny over in the corner here. You might see her. She's digging into the chair, causing a ruckus. We're all working in new ways this way. Anyway, about 2/3 of the methane going into the atmosphere comes from agriculture, primarily from cattle and sheep, and about 1/3 from fracking and from industry. So it turns out industry and agriculture are going to be really important to this one. Then we have another gas called nitrous oxide. which primarily about more than half of it comes from agriculture. It comes from overusing fertilizers and manure on farm fields, things that are rich in nitrogen. And when we use too much nitrogen on a farm, sometimes under the right conditions, it combines with oxygen and forms N2O and becomes a gas that leaves into the atmosphere, a very potent greenhouse gas. Some of it also comes from industry, but a lot of this comes from the agricultural sector, overusing fertilizers and manure. The last little bit is what we call fluorinated gases, or these so-called F gases. These are a weird set of chemicals that have very interesting chemical properties, but they're really useful. It turns out they make excellent insulators and refrigerants. We used to use something called chlorofluorocarbons, or CFCs, which is one of those kind of F gases, and we discovered that those were harming the ozone layer way up high in the upper atmosphere. We got rid of those for the most part and replaced them with hydrofluorocarbons, or HFCs, that don't hurt the ozone layer in the upper atmosphere, which is great. The problem is CFCs and HFCs turn out to be a major greenhouse gas. They trap heat and cause more climate change. There are a couple other chemicals in this family. One's called sulfohexafluorine, or SF6. You might hear about that if you ever work with transformers or utility lines. It's a really good insulator that people use. Anyway, those F gases, they contribute about 2% of today's climate change. The problem is that number could quadruple in the coming decades as more and more people buy air conditioners and refrigerators and freezers, especially in newly wealthy countries where people are buying their first air conditioners, often in places that have no regulations. So we got to check F gases too. The point of this little pie chart here is that we've got to tackle energy, materials, and land use and agriculture in order to tackle climate change, because that's where those gases come from. It's not just fossil fuels. That's the biggest part of it, but it's not the only part. And we've got to look across the whole board here of exotic materials, agriculture, land use, and the energy sectors. So that's kind of where the gases all come from a chemistry point of view. But I'm going to show you some other stuff here about where the gases come from and where they go from kind of a more sectoral point of view, which is kind of interesting. So here's a picture of the atmosphere. Imagine the atmosphere is like a big box in the sky. Actually, maybe you can even think of it like a bathtub, where you fill it up from the faucet, but you can empty it from the drain. You can both add and subtract things from the atmosphere. You can put them in and you can take them out. So we're going to show you this a little bit. The atmosphere can have sources of greenhouse gases. These are the major sources of today's greenhouse gases, now re-estimated in terms of their economic activity. We'll go through this in more detail, but you see electricity and food and industry and transportation, the things that we do that release greenhouse gases into the air. Well, let's say we put 100 units of greenhouse gases into the air. Guess what? Not all of them stay there. It turns out that nature does us a very big favor and removes a little over 40% of this greenhouse gas burden. A big chunk of it is taken up by land, primarily forest, by unmanaged forest, just nature doing its thing, and another big chunk by the oceans. And it leaves behind a little less than 60% of the greenhouse gases in the atmosphere, building up year over year, causing more climate change. This little picture, we call it the rainbow diagram in Drawdown. This is probably the most important picture you need to look at to understand what's going on with greenhouse gases and climate change. The left-hand side is us. That's humans dumping pollution into the sky, and it's causing more climate change. On the right, at least for now, nature's doing us a huge favor and removing about 40% of that pollution. That's fantastic. Otherwise, climate change would be a lot worse than it is already. So we can look at both sides of this equation. How do we lower the additions of greenhouse gas pollution? How do we lower the faucet, if you will, going into the atmosphere? But also, maybe how can we help out nature remove some of these greenhouse gases, maybe even more than we're doing today? So to achieve drawdown, to get to that point where we stop climate change, we can do two things. Here's today's picture. We're putting in a lot more pollution than nature can take out, and so the greenhouse gas levels are building up. But what if we started working on the sources of the pollution? We started to dial them down to zero. We replace the way we make electricity. We change the way we make food and how we do industry and how we do transportation, all that. If we can bring those down to zero, and we help maintain nature's capacity to help remove some of these greenhouse gases, we can then bend the curve and remove more greenhouse gases than we put in. We can empty the atmosphere of pollution and restore it back to something like normal in the long run. But for now, we can just stop climate change before it gets any worse. So when we think about climate change, we have to think about the sources of pollution. That's the place to focus most of our attention, as well as this removal mechanism, which we call sinks. That's just a fancy word for removal. So sources and sinks turn out to be the big crucial elements of addressing climate change, and we're going to need them all. So when we think about the solutions to climate change, first rule is stop the pollution where it begins. Start it from the beginning. It's a lot easier to prevent pollution than to try to remove it from the atmosphere later. So let's start with reducing the emissions of greenhouse gases and bring them down to zero over the coming decades. So this is this left-hand side of the diagram. Well, where do we act? Where do we go? Well, it turns out these are numbers for the whole globe. If we looked at them country by country, they would vary a lot between, let's say, the United States and Australia and China or Finland or New Zealand. All of these countries would look very different, but the global picture looks something like this. About a quarter of climate change greenhouse gas problem comes from electricity. That's burning coal and oil and natural gas, primarily coal and gas, to make electricity. Okay, we already know about that one, and we're going to fix that. Another quarter of climate change, which people are very surprised to see how big it is from agriculture and the food sector and land use. Basically, making electricity and making food together is about half of what causes climate change today. Those are the two biggest things we need to work on. Then we have the entire industrial sector, making everything we use and disposing of it. We have transport, moving stuff around. We have buildings, at least what buildings themselves emit. Of course, buildings consume electricity and they have industries happening within them, but this is what buildings release within the building itself, from a furnace, a hot water heater, a boiler, whatever. And then everything else, the remaining 10%, a lot of which is actually refining oil and natural gas and using it to make other things. But the first 5 sectors, electricity, food, industry, transportation, and buildings, are 90% of climate change, or just those 5 things. So let's focus on them. Let's take a look at those 5 big areas. Electricity, quarter of the global climate problem. Well, electricity is produced again by burning coal and natural gas for the most part, and it's used in major industry settings as well as in buildings. Those are the main uses of electricity. We send about half of it to our buildings, about half to industry, and a couple other things. So we can change both how we make electricity, the supply of electricity, but we can also change the demand for electricity in buildings and industry. So we can both be more efficient with our use of electricity and reduce the overall production need, and we can make it better and greener with renewable energy. But the first thing we've done at Project Drawdown is we always start by looking at efficiency, because you can do that today. You don't need to build a new power plant, you don't need a solar panel, you don't need a windmill, you just need to be more efficient. So we've evaluated a whole bunch of efficiency measures that can reduce the global demands for electricity. And I'll show you some of the numbers for that later. A lot of them are in buildings, but some of them can also be in industrial processes. Lots and lots of ways we can be less wasteful with electricity. Even if it's still using coal to make it, we can maybe cut the demand in half if we got more efficient. But then in parallel, we can also make electricity from non-carbon emitting technologies. For example, solar energy, or wind, or hydropower. Ocean power is pretty interesting. Geothermal, biomass, nuclear. We can use waste and turn that into electricity from landfills, methane capture, and so on. And when we look at all the solutions to climate change, we've evaluated the ones here. What we're showing here is different solutions in the electricity sector that can help us with climate change, drawn as little circles. Here, each circle, the size of the circle is proportional to the size of the solution. So the bigger the circle, the bigger the impact it could have on addressing climate change. Really good. Some circles actually have two circles within them, kind of an inner one and an outer one. That represents a range of what we think are kind of possible ranges over the next 30 years of what that solution could look like. So it's kind of a large error bar, if you will, kind of a range of numbers. So these are the electricity solutions, enhancing the efficiency of what we use today and then shifting production to greener, low carbon or zero carbon electricity tomorrow. We can do all of that. In the food sector, another quarter of climate change, about equal to electricity. We also have to address climate change as well. And it's kind of surprising how big this number is. Food is a huge contributor to climate change, but people sometimes get it wrong on what within the food system are the big culprits. Sometimes we hear about food miles, that we ship food from one part of the world to the other. Actually, that doesn't matter that much. All the energy used in moving food around the planet is actually pretty small. And sometimes it's not the distance we move food, it's how we moved it. Was it in a truck or a ship, airplane, a train, all that. It's not food miles. It's not organic either, or conventional. That doesn't matter either that much. Or GMOs, that doesn't matter much either. It turns out the big contributors to the food emissions for climate change are first deforestation, burning down forests to create new agricultural lands. Especially today, that's happening in the tropics, mostly in the Amazon and in Indonesia. In those areas, primarily this land is being burned down to make way for cattle and soybeans as animal feed. Those soybeans are not being used as plant-based diets. This is animals and animal feed. So that's why animals are so important. And the third would be palm oil, which is another important ingredient in the global deforestation issue. So it's animals, animal feed, and palm oil are the biggest drivers of deforestation. Then we have methane, which comes from animals and a little bit from rice fields. The animals, again, are mostly cows and cattle, so it's beef and dairy production for the most part. We'll talk about this later. You're going to hear a lot of kind of crazy stuff about regenerative agriculture, that methane doesn't matter because we'll just absorb it in the soil somewhere else. That's not really true. The methane emitted by our livestock and dairy operations is huge. It is a real massive climate problem, and we have to address it. We're never going to get rid of all meat, but dialing it down a lot could help, and then growing it better, which we'll talk about later through what's called regenerative agriculture, can help too. We need to look at both aspects of that, reducing the demand for these products and growing them better. Then third is nitrous oxide. That's kind of overusing fertilizers and manure. Again, too much nitrogen out in the farm field can turn into N2O into the atmosphere. So the big drivers of how the food system causes problems with climate change are deforestation for cows, for animal feed, and for palm oil, pretty much. Then we have methane, mostly from cattle and other livestock and dairy operations. And then we have nitrous oxide for too much fertilizers. Everything else is the other 5%. So when we think about this, we again, just like electricity, we can be more efficient with the food system we have today. And even as we learn to grow food differently, we can today do things like reduce food waste. It turns out about a third of all the food grown on the planet today is never even eaten. In rich countries, we tend to throw it away near us, the consumer, but in poorer countries, it tends to be lost closer to the farmer, between getting to the farmer's field to the marketplace. So we lose not only the food, the farmer loses their income, which is a kind of a double tragedy. So if there are ways we could reduce food waste, again, it's a whopping third of all the food produced, we could cut down a third of greenhouse gases, a third of the land use, a third of the biodiversity and water impacts. So this is one of the most crucial issues facing the world today in the environment is food waste, a really important area to focus on. Another area, because I mentioned how important animal agriculture is to climate change, but to everything else. Of all the land used in the world to farm, 75% of it is used to grow either meat or the feed we give to meat animals. So 75% of all the farmland is for animal agriculture, and a lot of our climate change emissions also tied to animal products. So reducing the demand on animal products could help too. Now that doesn't mean everybody becomes vegan. There are a lot of folks in the world who benefit from some animal nutrition, no problem. But we could dial it down and maybe replace some of our diets with more plant-based diets. It would take a lot of the environmental pressure off the meat system on the environment. So again, this is the efficiency part. Reducing waste and a more plant-rich diet would help a lot. Then we can protect ecosystems that are currently being burned down, especially tropical rainforest, but also grasslands and peatlands and other areas are being cleared for new farmland. If we don't need to do that and we protect those farmlands, they can continue to hold carbon and maybe even absorb some more. And then finally, we can grow food better. We can be more efficient with it, we can protect our ecosystems, and then we farm in more regenerative or more kind of environmentally friendly practices. You're going to hear a lot about regenerative agriculture in the next few years, which is kind of like organic, but better. It's not only reducing the harm to the environment, it's actually undoing some of the harm we've caused before and restoring, kind of regenerating soils and ecosystems and watersheds back to a healthier place, which is fantastic. So when we put all this together, we see the biggest solutions, though, in the food sector tend to be diets and food waste, then protecting ecosystems from being cleared further, peatlands and forest especially, and then farming better, managing our nutrients and our tilling of soil and cover cropping and regenerative cropping systems. All of those things could help a lot. So that's electricity and food. We'll go through the next three sectors a lot more quickly because they kind of follow the same pattern. Let's get more efficient and let's find a new way to make things. In industry, we have to think about a whole suite of topics. For example, how we make metals, especially steel, cement, which I mentioned before, some of our chemical processes, and also plastics. Plastics is about 1 to 1.5% of climate change is caused by making of, using, and disposing of plastics. Sometimes you hear it's a bigger contributor to climate change. It's really not. It's about 1.5%, but every percent matters. So we should tackle that too. And plastic has a much bigger impact in other areas as well, including ocean pollution, habitat destruction, and so on. So that's a topic we really need to think about. So we can be improving our materials. We're going to focus here on things like cement and plastics. We can tackle these so-called refrigerants that were used in air conditioners, freezers, refrigerators, and so on, those hydrofluorocarbons. Make sure that we're making them better. Maybe we switch to new materials that don't add to greenhouse gas burdens. We could also get smarter with our waste and use it again as a material or maybe as a source of energy. So we've looked at a few different industrial solutions. We're adding a lot more at Project Drawdown, but these are the ones we've evaluated already. And we see a lot of them matter quite a bit, especially the refrigerants, which is one that people don't usually think about. Then we get into transportation. Globally, about 14% of climate change is caused by our transportation today. And most of that is actually on road transportation. 10 of that 14% are cars and trucks, basically. Flying is a little less than 2%. It's like 1.8%. And everything else is the remaining 2%. Flying sometimes gets people kind of riled up. Flying is less than 2% of climate change, period. You're going to hear people multiply it by other things called radiative forcing and try to make it sound like it's 6% or 10%. It's not. It's 2%. It does have other impacts because when a plane flies in the air, it leaves behind contrails of basically condensed water vapor. Essentially, they're clouds, just made out of water vapor. So do other things. Ships do that. Other things do that. They have a very short-term temporary warming effect in the atmosphere if the sky is clear during the daytime in the summer. It's very localized, not a big impact globally, and it goes away in a couple of hours. Other things affect climate too, like clearing a forest warms the local air right under where the forest used to be. Building cities causes an urban heat island. We don't count any of that stuff either as a global climate change issue. So when we talk about flying, it's 1.8%. Sometimes there's confusion around that. Just stick to the real math, and it's about a little less than 2%. But in transportation, we can talk about all these things. We've got to tackle everything: aviation, cars, trucks, planes, boats, everything. And again, we can start by making the current mode of transportation more efficient, getting hybrid cars that still burn petrol, but they use less. More efficient trucks, more efficient aviation. Airplanes that fly, but airplanes today are about twice as fuel efficient as they were 20 years ago, but they could be even better. Ocean shipping could be even better too. But then we could shift to other ways of imagining transportation that don't rely on fossil fuels at all, like walking, bicycling, public transit, high-speed rail, or what we're doing today, telepresence and video conferencing. These are things that are alternative modes of transportation, essentially, and can reduce greenhouse gases as well. And then we can do things like electrify a lot of our vehicles. Cars and trains and trucks can be electrified. And if that electricity is made with renewables, then it can be totally carbon-free. It's fantastic. Aircraft are going to be pretty hard to electrify large aircraft, those small ones could be. We're going to think of other solutions for that down the road. But right now, again, being more efficient, shifting to alternative ways of doing things, and electrification seem to be the most promising solutions to reducing greenhouse gases from the transport sector. Okay, now we got buildings. And buildings are pretty interesting because buildings directly emit about 6% of our greenhouse gases. That is what they emit from the building envelope itself, a furnace, a boiler, a hot water heater that's maybe burning natural gas or something like that, or refrigerants that are leaking out of a building. So, but buildings also use electricity. They're also where cars go. So sometimes you'll hear buildings kind of have a shadow footprint that's maybe as much as a third or even half of climate change in some places. Yeah, you can make that argument. But in the accounting schemes, we usually kind of look at where the building emitted directly versus indirectly at the power plant. So this is the direct building emissions, just to be clear. It's about 2-to-1 residential emissions to commercial building emissions. So of that 6%, 4 of it is residential and 2 is everything else. And one of the things we have to think about is we can make new green buildings that are be better than the old buildings we have. But for the most part, for the next 50 years, most of the buildings we'll see in the next 50 years have already been built. There are hundreds of millions of buildings on Earth, and we're going to have to retrofit all of those as well as build everything new better than it was before. So a lot of the efficiency gains we're going to see is retrofitting buildings to be more efficient with the use of energy. Thermostats, building envelopes, low flow fixtures, maybe retrofitting to net zero buildings that generate electricity and use a lot less. They can shift the energy sources they use from, let's say, natural gas to electricity and using heat pumps or using solar to heat the hot water instead of oil or hot water from natural gas. We also need to make sure that within buildings, the refrigerants we still use are not leaking out of a building air conditioning system or out of refrigeration and freezer systems. So we can find lots of solutions to buildings here too. Now, the other category, the remaining 10%, I'm not going to talk about that today, but there are solutions there as well, especially capping natural gas infrastructure, making sure they don't leak. Eventually, we need to phase out fracking and natural gas altogether. That's going to take a little while, though. In the meantime, today, we should have done this years ago, we should plug all the leaks of natural gas pipelines and wells and everything to make sure what we call fugitive emissions, kind of unnecessary, unintentional emissions of leaking methane, don't get into the atmosphere, because that's so dumb. We should be able to stop that soon. So these are all the places we can reduce emissions and basically reduce sources. But over here, we can look at the sinks of carbon and other greenhouse gases besides carbon dioxide. And those are mainly on land and in the ocean. As I mentioned before, the land surfaces of the Earth, primarily forest, absorb about 1/4 of all the greenhouse gases going in the atmosphere, and oceans around 17%. And that leaves behind a little less than 60% of the total greenhouse gas emissions picture. On land, what's happening here is so far the sinks of greenhouse gases have primarily been in natural ecosystems, not agriculture. And they're primarily because of photosynthesis. Trees will do more photosynthesis. As the CO2 levels in the air increase, they can grow a little faster. They accumulate a little bit more biomass or wood, essentially, and they can add a little more carbon into the soils as soil organic matter or humus. And when we want to preserve these land-based sinks, we can help reduce the demand on clearing those forests by reducing food waste and changing our diets. We can protect ecosystems being cleared, but then we can put other land into play. This is what gets really interesting. Besides natural landscapes that we could take the pressure off of, we can turn to our farmlands and working landscapes and deploy these regenerative agricultural practices that can rebuild the soils and maybe even the biomass above, like in tree farms and agroforestry. we can restore those landscapes to be better and accumulate carbon in soils and vegetation. This is tremendously exciting, although unfortunately some groups are really overhyping how big these numbers could be. This is an important set of solutions, but it is not the solution. There was a recent report from the Rodale Institute, who I love. They do great work in organic farming, but they made a very reckless claim saying that regenerative agriculture could absorb all of our greenhouse gas emissions. That's absurdly not true, and it got a lot of pushback from scientists who work in this area. So we got to get our numbers right here. But despite that, regenerative agriculture is a great idea. It's good for farms, good for the environment, even besides climate change, and it's one of the many solutions we could use to combat climate change too. And we can also try to restore degraded lands, not just the working lands we have now, but the working lands we used and beat up. We can bring them back to health and restore them to maybe active production or some kind of ecosystem. So we put all these land sink solutions together. We have things that can be farming better on the left, protect the ecosystems in the middle, and maybe restoring those degraded lands to the right. Those would all be really helpful. Oceans also naturally absorb a lot of our greenhouse gases, primarily CO2. Oceans absorb greenhouse gases 3 different ways, it turns out. One is called a solubility pump. Pump just means kind of taking it out of the air and putting it into the water. The solubility pump is just CO2 chemically dissolving in water, just like a carbonated beverage, like a soda or beer or something like that. And so that's pretty exciting. But the problem is, as the oceans warm, their ability to hold CO2 actually goes down. So cold water can absorb more CO2 than warm water. So we don't expect that number to go up. If anything, it might go down slightly. The second way the oceans absorb CO2 is through what's called a carbonate pump. What happens here is CO2 is taken out of the water, usually by a living thing, like a shellfish, let's say oysters or clams, mussels, or by coral reefs. And what those organisms do is they take seawater and they take carbon out of it and calcium out of it and form calcium carbonate to make a shell, either in coral reefs or in shellfish. And those things hold carbon in those kind of rocks and shells for very long periods of time. That's pretty exciting too. The last area is so-called biological pump. That's where plants in the ocean, either kelp, kind of big leafy plants that float around in the water, or microscopic plants like phytoplankton and diatoms, they do photosynthesis and absorb CO2 into their biomass just through like a regular plant. And when they die, they can settle down on the ocean floor and stay there for long, long periods of time. That's what nature does. What we humans could do is figure out ways to maybe accelerate those 3 things, especially the biological pump, maybe with kelp farms, or the carbonate pump by growing more shellfish, maybe oyster farms, things like this. Those would be pretty interesting. Or accelerating the natural weathering of rocks. That's part of what's called a carbonate silicate cycle that buries carbon material down deep in kind of ocean sediments. So that's kind of an interesting idea too. We're working right now on a whole bunch of different ocean solutions and analyzing them. There are a few been proposed, but very few have been assessed independently. And later this year, early next year, we should be presenting some really cool ocean solutions and how big they might be. A third area, which you'll hear a lot about, but right now it's not really happening yet, just some prototypes and some interesting science experiments, are building machines that could take CO2 and other greenhouse gases out of the atmosphere and pull them out of the atmosphere for good, either to lock them up and sequester that carbon in maybe a geologic reservoir deep underground, pump it away forever, or better yet, I would love to pull greenhouse gases out of the air and make stuff with it. Maybe we could pull CO2 out of the air with a machine and make our plastics out of it. Why do we need to use oil? Leave the oil below ground, but if we need something like a plastic for like a heart valve or good Tupperware, I don't know. Maybe we could pull it out of our pollution, out of the sky, and turn it into a useful product. That would be pretty cool. Or jet fuel. We're still going to fly jets in the future. Military and civilian aviation will still be flying with some aviation fuel. But instead of using fossil fuels, why don't we mine the atmosphere, pull pollution out of the sky, and make it a jet fuel? We can do that today too, it turns out. We just haven't learned how to scale it and make it economical yet at large scales. But the technology is very close. So here are ways we can kind of absorb greenhouse gases through sinks on land and oceans and maybe with machines. So together, reducing the sources of pollution and enhancing the sinks of pollution can help us get to drawdown. But there's a third area I haven't mentioned yet. It turns out besides sources and sinks, we can also work across society. It turns out that a lot of things we do for other reasons that don't have anything to do with climate change, especially around fostering equality, turn out to have kind of a domino effect in helping us address climate change too. Specifically, when we help, well, for example, getting more access to healthcare and education for girls and young women around the world. As the parity in education and healthcare of women and men gets closer, women tend to have fewer children, but healthier children who are more likely to survive. Also, children may be later in life as they pursue other economic opportunities and get married or couple up later in life. So this slows down future population growth, which will also have some impact on climate change down the road. But it's without coercion. This isn't population control. Those two words should never be used in the same sentence again. Instead, this is helping to lift people up and provide opportunities, and then they can choose what they want to do with that. But what we find is with more access to education and healthcare, women make different choices that are healthier for them and their families and their communities, and maybe for the planet too. We also find that when we help indigenous communities help protect their landscapes, especially forest, that indigenous communities tend to manage forest in ways that absorb more carbon, are more productive, and are more biologically diverse than the counterpart landscapes elsewhere around them. So again, maybe we didn't do this for climate change, but fostering equality along genders, helping indigenous people protect their land. These are good things to do regardless of climate change, but they set up a whole bunch of other things that help us with climate as well, kind of a win-win. So when we put it all together, it's really clear there's no one solution to climate change. It's not just renewable energy. It's not just better farming. It's not just protecting forests, educating girls. Nope, nothing will solve climate change by itself. We got to do a lot of things. We got to do them all at once. So we can look at ways of reducing the sources of greenhouse gases in electricity, in food, industry, transportation, and buildings. I showed you some of those before. We can work with nature and support its sinks of carbon, especially right now we know how to do that on land, but we hope to grow the ocean solutions and maybe some of the engineered kind of machine-based solutions as well. And then, of course, things we do for other reasons around education, healthcare, and fostering equality, those also can produce climate solutions as well, kind of indirectly. So when we add up all of those circles, which each represent a suite of solutions, it turns out we have enough already to address climate change. Let me show you. If I put together everything I just talked about and did all of them, we can actually change the future of our planet. Here's what would happen if we do nothing else. The red curve is kind of our best guess as what society would do over the coming decades based on our current kind of energy and agricultural technologies and policies. It's just a guess, but that's kind of the business as usual scenario. But we can do two, or many other things. For example, this yellow curve and this green curve show what we call kind of drawdown scenarios. These are where we deploy the solutions, I should say, I showed you before, about 80 of them. If we deploy all 80 or so of those solutions, in scenario 1, we're pretty aggressive about it. In scenario 2, we're wildly aggressive about it. We find we can stop climate change around the mid-2040s at the earliest, and maybe by the late 2050s, early 2060s at the latest. And if we do that, it would stop the warming of our planet. Right now it's a little over 1 degree warmer. We could stop it at about 1.5 in the most aggressive scenario, or maybe up to 2 degrees in a more moderately aggressive scenario. If we don't do anything, we're headed to 3 or more, and that could be a big, big problem. So we do have right now enough solutions to do the job. As other technologies become available, we'll add them in. But right now we should use what we have today and just get them out the door as fast as possible. No more waiting. We've waited far too long. Let's get moving. Well, of course, there are going to be people who say we shouldn't do this. They're going to say it's too expensive or whatever. No, that's a lie. It's not true at all. We've analyzed the economics of that and find, yes, up front, you do have to spend some money. This is what economists will call a cost curve. Basically, on the horizontal axis, those are the solutions all stacked up, and they total the total amount of carbon they would avoid or take out of the atmosphere. The vertical axis shows what will it cost. If it's above the line, it means it costs some money. Below the line, it means you made some money. Well, initially, yeah, you get to pony up a little bit of money. It turns out about 20 to 30 trillion dollars. But if we do this and we do it over about 2 to 3 decades, we actually make between 90 and 150 trillion dollars back. This is incredible because we're going to save a lot of money. We'll make new revenues. And in fact, this is probably the biggest business opportunity in human history. So when people tell you it's not economical to address climate change, what they really mean is it's not very convenient for some very powerful people, especially in the fossil fuel industry and big agriculture. That's what they really mean. But for the rest of us, the other 7.5 billion of us, it's actually a pretty good day at the bank because we'll save money and make money, and everything we're doing here would make the world better. And by the way, this doesn't even count the damages climate change would cause if we don't do anything. And that could be uncalculable, trillions and trillions of dollars beyond this. So if somebody says it's not economical to address climate change, they're flat out wrong. It's not economical to ignore it. We have to pay attention to it. So every business leader and every capitalist in the world should be on the climate change solutions bandwagon because it's good for them too. So what have we learned? We've learned a lot here tonight. First of all, it is not too late to address climate change. Yes, the planet's 1 degree warmer than it should be. I wish we'd stopped it earlier. Scientists, we've all been talking to you about this for 30 to 40 years, really loud, but we waited and it got 1 degree warmer. But we can stop it from getting a lot worse. We can stop it at 1.5 to 2 degrees that is entirely within reach. We can do it with solutions we have now. What we have to do is scale the technologies and solutions we have available today. Rather than waiting for the new tech, let's use what we have today and do it now. Actually, at Drawdown, we say now is better than new. Using today's technologies today is way more important than developing tomorrow's technology. Let's do both, but first scale what we have now. So I talked a lot about solutions. If we deployed those 80 things into the world, we can stop climate change and make the world better and make a lot of money for everybody in the process. That's great. So why isn't it happening? Well, what we need to do is not just find solutions. We have to look for the things that make solutions actually happen. We call these accelerators. They're basically the things that push solutions out into the world and grow them. So what do we need to do to get solutions to grow? Well, we got to change the rules. Those are policies, regulations, laws, how taxes are done, how incentives are made. We have to shift capital, basically move a lot of money from out of bad things like fossil fuels and bad agriculture into good things like renewable energy, regenerative agriculture, protecting nature, increasing equity around the world. This could be a huge transfer of capital, but it'll be good for us. We got to change the rules for business because markets are good at solving some problems, but if they aren't given the right kind of incentives and the right guardrails, they'll do things that are kind of crazy. But if we tell them, hey, destroying the planet isn't a good business model, maybe business could be helpful and adjust and do good things. Technology is important, but don't wait for it. We have enough now, but if we bring in more technology and fold it in as we go, that's a good idea too. And yes, behavior is important too. Our individual choices do matter, but just not going to be enough. What we need is policy and practice at all levels, including our own. Things like food waste, energy efficiency, a lot of that is within our own personal reach. Not everything is going to be something we can solve by ourselves, but we can help out. And so why don't we look at all levels of agency, from the personal to the kind of community to the business to the national level to the international level. If we work together and use every kind of tool in our toolbox, we can make this happen. And we're going to be at it for a while. Solving climate change will not happen overnight. We got into this over a couple hundred years, especially the last few decades. It's going to take a little while to undo it. If we think about climate change solutions deployed over the next 3 decades, let's say, the first things I would do is deploy the things we know make money now, are simple, quick wins that work today, like energy efficiency. Let's make cars, let's make buildings, let's make industrial processes far more efficient. We know how to do that. We could lop off half the problem right there. Food waste. A third of the food, a third of the emissions, we can tackle that. Deforestation, it's not planting new trees, it's just stopping to burn down the ones you've got. We can tackle those today. Methane leaks from fracking, from wells, from pipelines. Let's plug the leaks, even as we start to undo natural gas over the long run. And then, I wouldn't have said this 5 or 10 years ago, but switching to renewables instead of fossil fuels actually makes money now. In fact, today's technologies for renewables, especially solar and wind, are cheaper than almost every other form of energy. So what we have here is what's called the kind of levelized cost of electricity. How much money does it take to make 1 megawatt hour? Utility scale solar, that is solar over a large farm, wind farms, are cheaper than gas, cheaper than coal, way cheaper than nuclear, and cheaper than peaking gas plants. So this is the obvious low-cost alternative for energy. And that's what we're deploying. Over the next decade or two, now looking at over maybe not just a 10-year horizon, but a 20-year horizon, we've got to talk about infrastructure. We got to rebuild everything. We got to change the way all of our farms work. There are hundreds of millions of farms on the planet, and we need to change some of the ways they're doing things to be more regenerative and better for the environment. We have to remodel every building on Earth. Every furnace, every water heater, every hot boiler, everything will have to be removed and replaced. Also retrofits for energy efficiency, for better transportation, all of that needs to be done. Our transportation infrastructure needs to be updated as well. We can do more electrification. We have to have charging stations. We need more high-speed rail, more public transit, more video conferencing, better ways of getting around aviation, maybe more trains instead, all of that. We have a lot of work to do on these big infrastructure changes, and that's going to take a little while. And then over the next 3 decades, I'd say this is where we still need some very heroic new technologies to help kind of finish off the problem. For example, we need to find very credible new ways of making cement that's cost effective, that don't release CO2, or new kinds of refrigerants that can replace the fluorinated gases with something that will contribute to climate change. Or carbon-free steel, maybe even carbon-negative steel. Is that possible? What about jet fuels? Can we make carbon-neutral or carbon-negative jet fuels? Absolutely we can. We just don't know how to do it cost-effectively right now. But over the next 2 or 3 decades, we can do that. The sooner, the better. So to me, I actually look at climate change. Yes, it's a very serious and sometimes depressing problem. But if you start to go beyond that and you kind of process how kind of scary it is, and you get through that, you start to see it maybe as, hey, there are opportunities here to make the world better, not just for climate change, but for a lot of things. It turns out we get to reimagine the world and rebuild it all. And along the way, not only can we address climate change, we can address other environmental issues, certainly around biodiversity and water and forest and ocean health and all of that. We get to reimagine how we live. And things like equity and justice and community and resilience, all of these things that we value can also be improved. So I think climate change represents kind of a reboot opportunity for the planet, because we're heading off in some pretty strange directions right now. But if we're smart and we're clever and we have good hearts, we can maybe pull back and push ahead in a much better way and build a world we can be proud of. And all of this is possible and within our grasp. But we need something else too. I talked a lot about the science and technology, a little policy and capital and all that stuff, but we need something more than that to get there. And I personally think we need a different kind of leadership, one that articulates a bold vision of the future, a vision that we want, a vision of the world we'd like to live in. I, for one, would like to have leaders who not just give us scary bedtime stories about how everything is terrible and those people are to blame. That's what we're getting from a lot of our political leadership, at least in my country right now. What we need instead is a leader who doesn't just bully us and tell us who's to blame, but maybe leaders who inspire us, ask us to come together and build a world that we want. We've seen this a few times in history. Martin Luther King didn't go around America saying, I have a nightmare. He said he had a dream. He died for his dream, and we're not yet finished with it for sure. But we're inching slowly towards a dream he first really articulated to all of us. He invited all Americans and all the people of the world to join together in building a future where children were judged on their character, not on their skin color. And we still can achieve that dream. It's just going to take some more time, sadly. But other visions like that, let's go build a better world and let's join together to build it. That's what I think we need. Rather than telling us how terrible everything is and tearing us apart, tell us how good it could be by coming together. And that's my ask of you next, is that you can help with that. Maybe we don't just rely on our elected leaders. Let's look at leadership in the mirror. All of you are leaders. All of you can change the communities around you and the people you interact with on a daily basis. So learn more about climate solutions, not just the problems, but what can we do about it? How can this help us? How can it make a better world for all of us? And share that with people you know and care about. That would be so great. I hope that we can be a resource for you along that journey. So can some others. But we stand by to be a free kind of public resource. We're nonpartisan, we're non-commercial, we're grounded in science. So I hope we can be helpful to you. Just come to drawdown.org and follow us on social media and keep in touch with what we're up to, and we'd like to help you with that. But most of all, what I want to ask you all to do as we close up here is to remember the future is not written yet. Don't believe anybody who tells you what the future is going to be, because we don't know. We get to build it. Tomorrow isn't done yet. We haven't even finished today. The future is up for grabs, and it belongs to those of you who are going to take that risk and accept the responsibility of consciously creating a future that you want.
Thank you for watching the Drawdown video. We are now rounding off the theoretical part of our course. The 9 first modules were about trying to understand the problem, the solutions, and the tool set that we need to create a more sustainable and ecologically responsible world. With the ideas of circularity, donut economics, and the drawdown of greenhouse gases in mind, we now have the tools to design our world. And that is exactly what we need to do. We need to design our way out of this crisis. The following 3 sessions are about you. If we want to avoid a breakdown of our world and design an ecologically and socially thriving future for our children and the generations after us, and the beautiful animals and creatures we share this amazing planet with, we will need to get everyone involved in the transformation. This is the largest overhaul in the history of humanity. It is also the greatest opportunity ever to create a more beautiful world our hearts know is possible, and it is a world we actually all long for. And more than ever, this transformation is necessary. So let us roll up our sleeves. We are already late in the game. Let's act now.